Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Hello learners. So how are you doing today? I hope you are doing well and always be happy. Welcome to Mathematical Economics channel. My name is Subhan Aziz Aludin. I'm from Mathematics Education Department, Faculty of Education and Teacher Training, Universitas Muhammadiyah, Professor Dr. Hamka, Jakarta. In this video, we are going to learn an important idea in finance. This topic is widely used in financial institutions such as bank and insurance company. Can you guess? Yes, it is compound interest. After watching this video, you should be able to understand compound interest and apply the idea in the real-world problem. So, pay attention.
What I want to do in this video is talk a little bit about compounding interest. And then we have a little bit of a discussion of a way to quickly, kind of an approximate way to figure out how quickly something compounds. Let's say I'm running some type of a bank and I tell you that I'm offering 10% interest that compounds annually. That's usually not be in the case in the real bank. You will probably compound continuously, but I'm just going to keep it a simple example, compounding annually. And then, how much is your money at the end of the period? By using the formula of compounding interest, you will have $100 plus $100 times 10% equals 100 plus 10. And then we have 110. What about if you deposit for 2 years? That means you are going to get 110 plus 110 times 10% is equal to 110 plus 11. Then you get 121. Now, can you figure out how much you have after n years? In this case, so we have to use a little bit of algebra. Alright, now we are going to use a little bit of algebra here to understand how compounded interest look like. For instance, we have a given principal P compounded annually at an interest rate R for a given number years n, and we'll have a value A at the end of the period. In this case, we are going to determine the future value based on present value, capital P. So we have, when we invest the capital P and we over the interest R which compounded annually. And now we are going to view our money at the end of 1 year. This one become our starting point, and we have capital P, and at the end of this period or after 1 year, our money become A. So A equals P, which is capital, plus P times R. So this money becomes P times 1 plus R by doing factorization. And now we are going to know this capital P if we save in the bank for 3 years. Right here. This one our starting point P, and at the end of the first year the capital P becomes P times 1 plus R. and this money becomes our capital in entering this period. So this capital at the end of the second year is P1 plus R plus P times 1 plus R times R. Remember, this value is our capital from the first year. And when we do factorization, this term becomes P times 1 plus R times 1 plus R. By exponential properties, this term becomes P times 1 plus R to the 2. Now, we can determine our money at the end of the third year. If you look at this term, P, and then P times 1 plus R, and then P times 1 plus R to the 2, so we can determine at the end of this period, our money becomes P times 1 plus R to the cube, right? Now, we are going to do the same thing, but we want to know for further times, for instance until n years. So it means by doing this one from the initial point or starting point, our capital P, it becomes this one at the end of the first year, and at the end of the second year becomes P1 plus R to the 2, and then at the end of the third year, our capital P becomes P times 1 plus R to the cube, and so on. And we want to know if our capital P is compounded annually until n years. So our money becomes P times 1 plus R to the n. Right? This is very simple algebra, and this one the idea of compounding interest. Now, what about compounding semi-annually, quarterly, or continuously? So in this case, now we are going to see if the interest rate compounded semi-annually. Now we are going to see for 1 year. So 1 year consists of 12 months. If the interest rate compounded semi-annually, it means we divide it for one year becomes 2 periods. It means from 0 until 6 months and 6 months until 12 months. Now we are going to see our money, our capital P at the end of the 6th month. So our money becomes P times R over 2. And then to make it simpler, we factorize this term becomes P times 1 plus R over 2. Remember, this term becomes our capital in entering in this period. So, can you determine this capital at the end of the 12 months? Yes, it becomes P times 1 plus R over 2 to the 2. Next, okay, what about if the interests are compounded quarterly? In this case, we divided 1 year become 4 periods, and this will affect our interest divided by 4. So at the end of this period, our capital P becomes P times 1 plus R over 4, because the interest that are compounded quarterly. So we have to divide it by 4. 4 is mean we divide 1 year divided by 4. So that's why we use r over 4. What about in this period? Our money become P1 plus r over 4 to the 2. What about this one? Yes, it becomes P1 plus r over 4 to the cube. And this one becomes P times 1 plus r over 4 to the 4. So now we are going to see how about if the interests are compounded continuously. Now, before we know determine if the interests are compounded continuously, we want to know if the interests are divided by m period for 1 year. So it means we divided 1 year becomes m period. So in this period our capital P becomes P plus P times r over m, or P times P plus r over m, right? So what about in this period? Our money become P times 1 plus r over m to the m. Now, by using this idea, we are going to determine our future value of capital P if the interest rate are compounded continuously. And we are going to apply some concept in the mathematics, so-called limit. Now, this one. So we are going to use this term because continuously it means the limit m approach to infinity of P times 1 plus r over m to the m. Since capital P is a constant, so we can write the capital P before a limit, right? This one equals P times limit m approach to infinity of 1 plus r over m to the m. As you remember that our lesson in the previous course in calculus 2, the limit m approach to infinity of this term, of this series, it becomes e to the r. So this value is equal P times e to the r. By using this idea, now we can determine our future value of P if r compounded continuously at the end of this period is P e to the r. Now we are going to next for the 1 year, where m is a number of times the interest is compounded per year, and we want to know for the n year. So look at this. So if continuously compounded with capital P and fixed interest rate r for n years could be depicted as this one, P and PE to the r, PE to the 2r, PE to the 3r, and the last one, PE to the n times r. Now we are going to do some example in the real world problem. And this case, if we are given the value of $100 at 10% interest for 2 years if compounded the first annually, semi-annually, and continuously. And we are going to know which interest can give more value in future value according to this type of compounded interest. Now, everyone can do calculation of this case, and you can use the previous formula to determine the future value of this capital. Now, I can give you some solution. Now, the first one, if R compounded annually, so we have to consider the term A equals P times 1 plus R to the n. So in this case, n equal to, then we have A equals P times 1 plus R to the 2. Since our capital P is 100, and we multiply 100 with 1 plus 0.1 to the square, and this term is equal 1.21, and we multiply 100 with 1.21, it becomes 1 to 1, 1 to 1, right? Now the second one, if in interest rate compounded semi-annually, so we have to consider the term A equals P times 1 plus R over 2 to the 2n. Then we have A equals P times 1 plus R over 2 to the 2 times 2. Since R equal 0.1, and this term become 1 plus 0.1 over 2 to the 4, and we multiply by 100. Right here, for the last one, we have $121.55. And the last one, what about if interest rate R compounded continuously? So we have to consider A equals P times E to the NR. By using this term, so we have A equals P E to the 2R, and we substitute the value of R, which is 0.1, and then we have 100 E to the 2 times 0.1, and we have 100 times E to the 0.2, and we get 122.14. If we compare the result in point A, B, and C, we can get conclusion. What is the conclusion? According to this example, so a given principal set out at the same nominal rate of interest rate will earn different effective rates of interest, which depend on the type of compounding. If the interest rate compounded semi-annually and continuously will give more money than if R compounded annually. So we can see from the value of the future value of capital P, which were $121, and the second one 121.55, and the last one 122.14. I hope you can get this idea, and then you can use and apply this in compounding interest to know about, for further knowledge about annuity and also insurance. So please practice and then make you familiar with this topic, and see you next video.
I hope that you enjoyed the video, and this topic will make you easier to understand for further concepts in finance, such as annuity and insurance. Remember, you can rewatch this video anytime and doing some practice problem. Thank you for watching this video. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.